3.6 is a long section, talks about rational functions. A rational function, r of x, is the quotient of n of x and d of x, where both of those are polynomials, and of course the denominator cannot equal 0. There are 4 properties that you have to find to sketch a graph of any rational function. You need to find the x-intercept, the y-intercept, the vertical asymptote, and the horizontal asymptote. It seems the horizontal asymptote is the challenge. So to get 1 point across, I'm making this note. Note that 1 over x approaches 0 as x approaches plus or minus infinity. Ooh, I put the infinity in the wrong place. There. So, let me elaborate. We're looking at 1 over x. If x equal 10, 1 over 10 is 0.1. If x equals, so as x grow to 100, 1 over 100 is 0.01. If x grows to 1,000, 1 over 1,000 is 0.001. If x grows to 10,000, 0. So are we in agreement that as x grow, we say 1 over x, the notation approaches 0. And what if I want to go to negative? What if I went to negative 10? Well, 1 over negative 10 is negative 0.1. What if I went to negative 100? Negative 0.01. What about negative 1,000? Negative 0.001. And negative 10,000? So again, as x approaches plus or minus infinity, 1 over x approaches 0. Actually, it turns out any number over x approaches 0 other than 0. That's something I'm going to hold you to as we work around these numbers. Couple of quick notes of these functions. If I'm looking at a fraction and I want to know where does the fraction equal 0? A fraction equals 0 if the top of the fraction equals 0. Of course, provided the denominator doesn't. 0 over 0 is undefined. And the key to this entire section is that a rational graph starts and ends. So it starts next to an asymptote and it terminates next to an asymptote. If you keep that in mind, a graph must cross through its intercepts. It must. Then you're pretty much set. So there's only one example, but as you see, we're doing tons of examples. We want to really hammer this down. So let's clarify. Find the asymptotes, intercepts, sketch a graph. Well, it turns out the asymptotes and the intercepts are a key for you to sketch the graph. Without those, you can't sketch a graph. So to make it easy, let's see. One vertical asymptote. And we're going to denote that by VA. 2. Horizontal asymptote. Three, Y-intercept. That's the easiest, because these are the graphs of functions. And 4, x-intercept, we set y equal to 0. And remember, when we set y equal to 0, a fraction equals 0 if the top equals 0. So, vertical asymptotes is fairly simple for students. That's pretty much whatever the domain doesn't allow you to draw a vertical line. So in this case, if I was to ask you what's the domain, you would say domain x cannot be a negative 2. That's your vertical asymptote. How that translates on the graph, you would show clearly on the graph a dotted line indicating x equal -2 is never allowed to be part of the solution. Y-intercept, I'm skipping step 2 as you see. Y-intercept, if you replace x by 0, that's very easy to find. Just hide the 0. Y would be 3 over 2. Remember, a graph must cross through its intercepts. 0, 3/2. Those intercepts are a key for me to sketch a graph. And to find the x-intercept, you set y equal to 0. So if you set this equation equal to 0, read the top. That reads 3 equals 0, which cannot work, meaning none. The graph doesn't cross this x-axis. Very good. Now let's go to the horizontal asymptote. Horizontal asymptote is something that in calculus we call limits. We're going to start talking about the idea of a limit, but not in full detail, barely. So this is how we're going to find the horizontal asymptote. We're going to look at the top and say, what dominates the top function? The top is dominated by 3. So end behavior of the top, end behavior of the bottom. The end behavior of the bottom is x is going to dominate over the 2. Right? Well, 3 over x, we agreed. Any number over x will approach 0. And that's really what horizontal asymptote is. Horizontal asymptote is always as x approaches infinity, plus or minus, what happened to the y? Y approaches, in this case, a 0. Now, I know you don't like that much. That's okay, because we're going to do only 18 or 20 examples. So, horizontal asymptote, we draw that. Now, generally speaking, a graph doesn't cross an asymptote. The vertical asymptote is impossible to cross, but the horizontal, sometimes the graph does. Now, I need to sketch a graph. The key, a graph starts next to an asymptote and ends next to an asymptote. You only cross an asymptote when you have to. So I start with the left. Start next to an asymptote. The graph either starts right there or right there. If it starts right there, it must end next to the asymptote. It's always a smooth curve. And if it starts on the bottom, but it can be both, because these are graphs of functions. It's either the top or the bottom. If you have a horizontal asymptote of y equals 0, you're going to have to pick a test point. So all what I need is a point to the left of -2, say -3, -10, -100. And all what you care about, if y is positive, you're here. If y is negative, you're right there. Well, the top is always positive because it's 3. The denominator, if you put a -3 there, -3 plus 2 is negative. Positive over a negative is a negative. I got the left half of the graph, just like that. The right half, the fact that there's an intercept is going to help me out. I have two options. Either, remember, a graph starts next to an asymptote and ends next to an asymptote. So either I'm going to pick up from here, go through that. Oops, I missed it. Can you believe that? Go through that. Oh my God. Third time will be a charm. Go through the intercept and end next to the asymptote. Or I start on the bottom. But if I start on the bottom, don't you need to go through that intercept? Well, I didn't get any intercepts there, did I? So I can't cross an axis without intercepts. It must be the top portion. If you want to pick points there, you can. There's no need to. And there it is. Again, I am aware that you're not very happy with this. That's always the case. But after, 8 or 9, probably you'll come accustomed to it. If not, 12 or 13. If not, 18 or 19. 1. What is the vertical asymptote? 2. What is the horizontal asymptote? 3 is the easiest. Y-intercept, no work at all. Put 0 for x. That disappears, that disappears. You're left with a 1 over -5. Excellent. And 4. X-intercept. So x-intercept, set the top equal to 0. Because when you set y equal to 0, right? The top equal to 0, none. Okay, well, how does this work? The vertical asymptotes I need to factor the denominator to figure out what the domain is. Normally, domain is all real numbers except x equal. That's what the vertical asymptotes are. Those are the values you're not allowed to have. Isn't that really x plus 5 and x minus 1? So where does the denominator equal 0? At negative 5 or 1. Those are the two values we're not allowed to have. Horizontal asymptote always requires some more dominance. What dominates the top? 1. What dominates the denominator? X squared. If 1 over x approaches 0, 1 over x approaches 0 even faster. So that's y equal, and again, kind of like a limit. So start with the asymptotes. X cannot be negative 5. 1, 2, 3, 4, 5. I'm rescaling this. And y cannot be 1. I'm going to leave it as the y as 1. I'm sorry. I messed up. I meant x equal 1. So you could scale the x differently than the y. X equal 1 is right there. Now, if I just mark the units, it's clear what they are. If you don't mark the units, you really have to tell me what those are. Now the green, where the graph is going to be, the graph is going to cross through 0, negative 1/5. 0, negative 1/5 is about right there. Okay. And the horizontal asymptote was y equals 0. That's why we didn't get any x-intercept. Well, a graph starts next to the asymptote and ends next to an asymptote. So the graph, the left start next to an asymptote, either it's going to look like this or like this. How am I going to figure that out? I'm going to choose a point to the left of negative 5, negative 6. The top is always positive. If I put a negative 6 there, negative 6 plus 5 is negative. Negative 6 minus 1 is negative. If you multiply two negatives, that's a positive. What does that mean? There's that piece. The piece in between, I have a good idea of what it looks like. I don't need to pick a test point. I could, because if you say I'm going to start at the top, don't you need to cross the x-axis to reach that intercept? I didn't get an x-intercept there. So it has to start on the bottom, hit that point. Now, does it go up or does it come back down? The fact that I didn't get an x-intercept there indicates that, you know what? That graph comes down. So an intercept helps a lot. The piece to the right either looks like this, starts next to an asymptote and ends next to an asymptote, left to right. Well, I need a test point to the right of 1, say 2. 1 over 2 plus 5 is positive, and 2 minus 1 is positive. If they're all positives, that's how the graph looks like. Done. Next function. Well, if I was you, I would factor those. That would save me a lot of time. So 1, vertical asymptote, x equals 0 and x equal negative 3. 2, horizontal asymptote. What dominates the top? X. What dominates the denominator? X squared, which is 1 over x. 1 over x approaches 0 as x approaches infinity. 3, the y-intercept. If I replace x by 0, that's easy. Put a 0 there. That's 1 over 0. That's undefined. That means none. The graph doesn't cross the y-axis. 4, the x-intercept. Set the top equal to 0. Where does x plus 1 equal 0? At negative 1. So start with my asymptotes first. I have an asymptote at x equals 0, negative 3. As long as I'm marking those, I don't need to label x equal because I am moving by 1 unit. The graph passes through the point negative 1, 0. This is an odd graph. That happens a lot. Remember, vertical asymptote is impossible to graph. Horizontal, you could cross roughly 15% of the time. So, how does it work? Well, the piece to the left either looks like this or looks like this. I'm going to have to pick a point to the left of, we said this was negative 3, this was 0. Say negative 4. Negative 4 plus 1 is negative. A negative right there. And negative 4 plus 3 is negative. 3 negatives will yield a negative. So it's right there. This piece, either looks like this or like this. I can't figure that one out. Well, I'm going to pick a point between 0 and -1. Say I'm going to pick, but to the left of the -1, right? I'm sorry, this is -3. I missed that. So say -2 in there. -2 as a test point. The top, -2 plus 1 is negative. A negative in there, that's a negative. And -2 plus 3 is positive. Negative over a negative is a positive. So that tells me that piece is right there. Now again, I'm still confused over, does it come down or does it go up? Well, a point between -1 and 0, say -1/2. Luckily, I only need the plus or minus. I don't need the value. -1/2 plus 1 is positive. -1/2 in there, that's negative. -1/2 plus 3 is positive. One negative will yield a negative, so the graph is below the x-axis. And the last piece, any point in there will do. Either the graph will look like this or like this. By the way, we're doing the longest case first. There are 3 cases. If I pick x equal 1, 1 plus 1 plus 1 is positive. A 1 in there, that's positive. And 1 plus 3 is positive. 3 positives will give a positive. There's the graph. So it starts next to an asymptote and ends next to an asymptote. So whenever you have a horizontal asymptote y equals 0, that graph takes the longest to sketch. And I'm doing those first. First case. Here, the same deal. I would say, you know what? This is really x minus 2 into x plus 2. All right, 1. Vertical asymptotes, x equal 2 and -2. Horizontal asymptotes, dominance. What dominates the top? 2x. What dominates the denominator? X squared. Isn't that 2 over x? As x approaches infinity, that will approach 0. That's my horizontal asymptote. 3. Y-intercept. If I replace x by 0, that's gone and that's gone, I'm left with -3 over 4. And 4, x-intercept, a fraction equals 0 if the top equals 0. Where does 2x plus 3 equals 0 when x is -3/2? So start with my asymptotes. I have 2 of them. X equal 2, x equal -2. Y equals 0. Again, this is the worst case scenario. This is the most work. The graph, 0, -3/4, and -1.50. All right. The piece to the left, well, it either looks like this or like this. I'm going to pick a point to the left of -2, say -3. -6 plus 3 is negative. I could put a -3 either in each one of those two, or I could just put a -3 right there. -3 squared is 9. 9 minus 4 is positive. Negative over a positive is a negative. There's the graph. Now, does the graph come up this way or come down this way? I know the right piece has to go through that point and terminate next to that asymptote. That's easy. But I'm not sure whether it comes above or below, so I pick a point between -1 and -2. Say -1/2. I'm sorry, -1, -1.5. -1.5 times 2. That is -1.5 is the actual crossing. -1.9. So I'm trying to choose a point between -1.5 and -2. -1.9. -1.9 times 2 is -3.8 plus 3 is negative. And -1.9 squared is less than 4 minus 4 is negative. The fact that the answer is positive, there it is. I know the rest of this piece. This has to go through that intercept and terminate next to the asymptote. It can't go up because I didn't get an intercept there. And the piece to the right either looks like this or like this. Well, a point to the right of 2, say 3. 2 times 3 plus 3 is positive, and 3 squared is 9. 9 minus 4 is positive 5, so positive over a positive is a positive. Now I'm going to continue this in the next video.